Okay guys, let's look at another angle. Maybe we'll use radians this time. Theta equals 315 degrees, which in radians, if we converted, 350 degrees times pi over 180. And that's going to give me 7 pi fourths. Okay, so start with our initial side. And let's do theta. Pi halves, pi, 3 pi halves, and finally 7 pi fourths, which is the same again as 315 degrees. Terminal side. Okay. Now, when I go to look at this, I want to look at the reference angle, or theta prime. So how much do I have left? Let's do degrees first if that's easier. How many degrees left do I have to get to 360? Well, 360 minus 315, 45. So I know my reference angle is a 45. Or we could do it as 2 pi minus 7 pi fourths. Convert 2 pi to 8 pi fourths. Minus 7 pi fourths, pi fourths. Or pi fourths. Okay, and as we remember, pi fourths, or a 45, and let's just finish constructing it how we would. We'd put our right angle there. And we'd think of our values. Well, a 45 in the first quadrant, x value is root 2 over 2, and y value is root 2 over 2. However, since we're in the fourth quadrant, x is positive, but y is negative. So let's put that negative symbol in. So if I were to write this as a point here, this would be root 2 over 2, comma, negative root 2 over 2. This location, this point here. So again, we're going to draw our angle, determine what theta prime here is. In this case was pi fourths, or 45 degrees, our reference angle. And then we're going to think about, oh, that's a 45, so I know the value of each side are the same, root 2 over 2 for each of them. And then I just have to think which one's positive or negative. Well, I've got positive x and negative y. Hence, here's my location and answer. Okay, let's use a reference angle to evaluate a trig function. Okay, how about the tangent of negative 240 degrees? Okay, let's draw our unit circle. put in our y-axis here. And let's put in our x-axis here. Okay, draw your initial side. Remember, put this little vertex. Draw out the ray. Initial side. And now, if it's negative 240, which way do we move? Remember, negative, we move in a clockwise direction. 90, 180, and then up here to 240. And let's extend it all the way to that unit circle edge, the radius of 1. Okay, negative 240, we can label. Now that's good, but more important now we want to find theta prime, our reference angle. And remember, that's our shortest acute angle down to our x-axis or up to our x-axis. In this case, well, how much did we go beyond 180? We went another 60 degrees. This would be my reference angle, 60 degrees. Okay. From there, I want to go ahead and draw the sides of my right triangle. Okay, so for a negative 240, I'm really looking at a 60-degree angle. My reference angle. So I know I've got a 60-degree angle. So this would be my long side, and this would be my short side. And how much is the long side? Root 3 over 2 for a 60. And how much is the short side? Of course, 1/2 always for these 30, 60, 90s. Now I'm going to think what quadrant I'm in. Well, I'm in the second quadrant here. Remember, first, second, third, fourth. And I'll say, oh, so I'm in negative x territory and positive y territory. So negative x, short side, and positive y, long side in this case. So this location up here is negative 1/2, comma, root 3 over 2. Okay. Just try to try. Okay, and that's my x, comma, y. Okay, let's construct, say, tangent. Well, to get to tangent, I can write it first. Tangent of negative 240 equals sine of negative 240 over cosine of negative 240. But really we're not thinking of that so much as we're thinking of our reference angle. Okay. So the tangent, negative 240. Well, sine, we said, corresponded to y. And cosine, we said, corresponded to x. Well, what's my y value of this? Well, I just said it. Root 3 over 2. Okay. And what's my cosine? Well, I said cosine corresponds to x on the unit circle. Negative 1/2. Now I've got a fraction over a fraction. What should I do to simplify? Well, I'm going to flip and multiply. And I'll, of course, cancel that out so that I know that I've flipped and multiplied. The 2's cancel, and I'm left with negative root 3. Okay, let's continue our discussion of using reference angles to evaluate functions. Maybe they give me cosecant of 17 pi 6. Well, let's draw our circle. around the unit circle. Initial sign, and then I'll rotate pi halves, pi, 3 pi halves, 2 pi. Well, 17 pi 6 minus 2 pi, and I convert, say, 2 pi to 12 pi 6. Sorry, that's minus. 17 pi 6 minus 12 pi 6 is 5 pi 6. So I have 5 more pi 6 to move here once I do a complete revolution. So what I did was I subtracted what a complete revolution was in radians from my original, and I'm going to keep going. 5 more pi 6. That's there. And let's put that angle in. Terminal side. And I'm going to go ahead and extend it out to my unit circle. Okay. So the cosecant of 17 pi 6 is coterminal with 5 pi 6, and the reference angle would be now from here down to here. Okay, so pi minus the 5 pi 6, which I have left. Well, let's multiply that by 6 over 6. That's 6 pi 6 minus 5 pi 6 leaves me with pi 6. So my reference angle here is pi 6, which hopefully have started to correlate in my mind with a 30-degree triangle. But if I didn't, of course, I could multiply pi over 6 times 180 degrees over pi and convert it to degrees. Pi's cancel. That's 30. That's 30 degrees. Okay, so my theta prime, the reference angle, is 30 degrees or pi 6. Okay. All right, so I remember for a 30 that this would be my short side here, and this would be my long side here. And my long side is root 3 over 2. And my short side is always 1/2. Okay, so if I'm gonna, but then I have to think, well, I'm not in quadrant 1, I'm in quadrant 2. So in quadrant 2, I'm essentially in negative x and positive y territory. So that would be negative x and positive y. So this location here is negative x root 3 over 2, positive y of 1/2. And remember, that's x comma y, and also cosine comma sine. Okay. Let me see if I can clear off some of this here and create some room to work. I'm getting to know this software here too, so bear with me. This is probably not the ideal way to do it. Let's paint over it. Okay, so we've so far constructed our angle, drew the terminal side, found the reference angle. So essentially a 17 pi 6 is the same as a 5 pi 6. And a 5 pi 6 has a reference angle of pi 6 because I then draw, of course, whatever the terminal side is, an acute angle down to the x-axis. And that was pi 6 or 30 degrees. I was able to construct my x and my y. And of course I thought about which is positive and which is negative. Okay, now, cosecant is the reciprocal of sine. So sine of 17 pi 6 essentially is 1/2. Once I've constructed my reference angle and found the sides, then I'm going to use these tricks essentially to get to know quickly what sine and cosine are, and then I can construct tangent and all my other ones from there, of course. Okay, so sine of 17 pi 6 equals 1/2, and hence cosecant of 17 pi 6 would just be sine done what? Well, flipped over 2 over 1, which is 2. So the cosecant of 17 pi 6, which is the same as the cosecant of 5 pi 6, because we just took out 1 revolution, or 2 pi from that 17 pi 6, equals 2. Box it in, that's my answer.